So in this video, let's discuss about the hash diagram. So some basics related to this chapter we already discussed. So I will solve two problems related to hash diagram, which is very important. In almost all the previous exam question papers, this question was asked. So it is very easy. So see the question. Draw the hash diagram of the set A under the partially ordering relations. Under the partially ordering relations, what is it? You see, divides, and check whether it is a totally ordered relation or not. So A is given as 1, 2, 3, 6, 12. So you don't have to check whether it is reflexive and antisymmetric, transitive, all those things not needed. So you first write the relation R. Okay. So what is the condition given? Divides. Now you see, um, in such type of problem, divides. See, 1 divide 1, that is self, 1 comma 1, then 2 comma 2, then 3 comma 3, then 6 comma 6, because each one is exactly divisible, right? Then 12 comma 12. Now you see, start in an order, don't get confused. See, we can write 1 comma 2 because 2 is divisible by 1. So 1 comma 2. You continue with the 1 only. See, next is 1 comma 3. So 1 comma 3, then 1 comma 6, then 1 comma 12, because why I am able to write all this is, see, 12 is divisible by 1, so like that you have to continue. So after that, 1 this is over, next you start from 2. So whether can we write 2 comma 3? 2 comma 3 we cannot write because 3 is not divisible by 2. In this problem the condition given is divides, so we can go for 2 comma 6, then we can go for 2 comma 12. Okay, then about 2 it is over. Now start from 3. So 3 comma 6 is possible, 3 comma 6, because 6 is divisible by 3. Then 3 comma 12 is also possible because 12 is exactly divisible by 3. So about 3 it is over. Next is to start from 6. So 6 will have only one option. So 6 comma 12, because 12 is divisible by 6. So that's all is remaining now. Now we are able to write the relation. Next is to draw the hash diagram. See how to get a clear picture about the correct way of hash diagram. First, what we will do is, I'll just, this is a rough one actually for us to understand. See, what are the numbers available? 1, then you see 2. In a straight line you write now, just for understanding. 3, then 6, then 12. Okay. Now we have relation from 1 to 1 to 2. That I will not do in this rough one. I'll just connect the other relations which are given in that set R. See, you can see, see self 1 you leave up to 1 comma 1 to 12 comma 12 you leave. Next you see there is a connection from 1 to 2. There is a connection from 1 to 3. There is a connection from 1 to 6. See, 1 to 6. There is a connection from 1 to 12. There is a connection from 2 to 6. There is a connection from 2 to 6. There is a connection from 2 to 12. There is a connection from 3 to 6. There is a connection from 6 to 12. Now you see what is missing here. What is missing here? Can you tell me? Is there any connection from 2 to 3? See, there is no connection. That means we cannot write 1, 2, 3, 6, 12 in a same line. So this information will get by the rough drawing the rough diagram only. So wherever there is no connection, instead of writing vertically up, you have to write sideways. So now I will start writing here. You observe this very carefully. See, now this 1 is at the bottom only, no change, 1. Then 2 and 3 I have to write adjacent. Here if I write 2, 3 I have to write adjacent. Why I am writing this? See, this hint I will get only when I draw this rough diagram. Otherwise you have to by heart. There is no point in by hearting. Don't waste your time. Then there is a connection between 6 and 12. So that let it be as it is. This is 6 and above that it is 12. Okay. Now you see there is a no, what is that? Self means, see, what is self? 1 comma 1, 2 comma 2. So all these loops you complete. You know how to do it. See, 1 comma 1, then 2 comma 2, then 3 comma 3, then 6 comma 6, then 12 comma 12. Okay, this is over now. Next is you check for next you continue. So 12 self is over. Next 1 comma 3. So there is a connection. Sorry, 1 comma 2 is also there. We'll go in an order. 1 comma 2. Next is 1 comma 3. Next is 1 comma 6. 1 comma 6. Yes. 1 comma 6. Next is 1 comma 12. 1 comma 12. 1 comma 12. Okay. After that 2 comma 6. 2 comma 6 is here like this. 2 comma 6. Okay. Then 2 comma 12. 2 comma 12 is there. 2 comma 12. After 2 comma 12, then we have 3 comma 6. See, like this. 3 comma 6. Then 3 comma 12. 3 comma 12. Then 6 comma 12. Okay. Now here this is not complete. Next what you have to do is you have to remove that the first one, that is self 1. Okay. First we will remove that, because you know the condition for drawing the HASSE diagram, if you refer the notes you will get it very clearly. So first you have to remove, what is that, reflexive. Reflexive first we will remove, then we will remove the transitive edges. Okay. So reflexive means, what is that reflexive? The 1 comma 1, 2 comma 2, 3 comma 3, all those things are reflexive. So in the next diagram that we draw, you have to eliminate that. Okay. So the next diagram will be like this. This is 1, this is 2, this is 3, this is 6, and this is 12. So all those reflexive we will remove. Then what are we going to do here is, see, we will continue with the you know that there is a, I'll see the first diagram only. You from there only you can understand this very clearly. There is 1 to 2 and 2 to 6. So 1 to 2, 2 to 6 is there. So in transitive that is 1 to 6. So 1 to 6 you don't have to write. Okay. So 1 to 2 is required. 2 to 6 is required. There is one direct from 1 to so 1 to 2, 2 to 6 is available. So 1 to 6, that is not required. Okay, you can remove it. In the same way, there is see, 1 to 3 is needed. 3 to 6. So 1 to 6 is not needed. Already we have removed. Okay. Next you see 3 to 6 is there. 6 to 12. So you don't have to consider 3 to 12 directly. That will be removed. Next you see 2 to 6 is here. 6 to 12 is also there. That 2 to 12 direct what is there, that comes under transitive, right? That will be removed. Okay. Next you see here there is 1 to 3 and 3 to 12. So 1 to 12 direct is also there, that you remove. That becomes the, that is the transitive. So now only this much is remaining. Next step, what to do? You have to replace that circle and with the dots. Then you can remove the arrow. That will be the final hash diagram. Okay. So now we will do that. The last step. So in the last step, instead of that circle, it is 1. Then this 2. This is 3. This is 6. And this is 12. Now you don't need any, you don't have to represent with the arrows. Just a connecting line would be sufficient. So 2 to 6 is there. Sorry, 1 to 2 is there. 2 to 6 is there. Then 6 to 12. Okay. Then here 1 to 3. Then 3 to 6. This is the hash diagram. So you don't prove that it is a total partially ordered relation by considering reflexive, transitive. All those things not required. Only this much. See the question. Draw the hash diagram under the condition divides. This much is what you have to do. Okay. So I hope this is clear. Now we'll move on to the next problem. So set X is given as 2, 3, 6, 12, 24 and 36. And here the relation is less than or equal to and such that X less than or equal to Y if X divides Y. See, there are two conditions. X should be less than or equal to Y and another one is X divides Y. So both should be fulfilled and you are asked to draw the hash diagram. So as like the previous problem, first we will have to write the set of relations. Okay. So R is equal to. Now you cannot only consider one X less than or equal to Y. No, it should also X divides Y. Now what is X and what is Y? First number what you consider is X. Second number what you consider is Y. So X divides Y means Y should be divided by X and you should get a integer. There should not be fractions. That's what you need to understand here. So since X less than or equal to, there are two things. X can be equal to Y, X should be less than Y. Both are acceptable. So first you fulfill X equal to Y conditions. Okay. How are we going to do that? You see. So all those, what is that? First condition is about the reflexive terms, no? So that you fulfill. See, equal to case 2, 2. 2 is divisible by 2, right? So 3, 3. Then 6, 6. Then 12, 12. Then 24, 24. Then 36, 36. So now all this is fulfilled. X equal to Y is fulfilled and X is divisible by Y in all these cases. Now you have to be very careful. Now X less than Y and X divides Y both. So you cannot write here 2, 3. Why? 3 is not divisible by 2. So that you don't have to consider. So next what you will do? Next is whether 2, 6 is possible. 2, 6 is possible because 6 divided by 2 is 3. Okay. In the same way, you start with all two terms first. That is 2, 6 is fine. Then 2, 12 is possible because 12 is divisible by 2. Then 2, 24 is also possible. So 2, 24 is possible. Next you start with the 2, 36. 2, 36 is possible because 36 is divisible by 2. Next all two terms are over. Starting from 3 you start now. So whether 3, 6 is possible. 3, 6 is possible because 6 is divisible by 3. Then 3, 12 is also possible because 12 is divisible by 3. Then 3, 24 is also possible because 24 is divisible by 3. Then 3, 36 is also possible. Okay. So 3 starting from 3 is over. Next to start from 6, next digit, that is 6 comma 12 is possible because 12 is divisible by 6, right? Then 6 comma 24 is also possible. 6 comma 24 is possible. Then 6 comma 36 is possible because 36 is divisible by 6. Then all starting from 6 is over. Next start from 12. See, don't buy at these numbers. You understand this and do it. So 12 comma 24 is possible because 24 is divisible by 12. Next 12 comma 36. This is also possible because 36 divided by 12 is 3. So 12 comma 36 is over. Next what? Can we write 24 comma 36? Even though 24 is less than 36, 36 is not divisible by 24. So you stop here. Okay. What is the next step? Next step, as I told you earlier, so always start with the rough diagram. Rough has a rough diagram. Okay, there we will come to know whether there is connection between each and every term. If there is connection, then vertically you can write. If there is no connection between one term and its neighboring term, then you have to write adjacent, just like the previous one. So let's see how to go ahead. Okay. So what is the first lowest one is, start from what is that, 2. Okay, 2. Then it is 3. Then it is 6. Then it is 12. Then 24. Then 36. Okay. So once you do this, next this one, the reflexive you don't have to do because that has nothing to do for us. Let's start with the others. Okay, so up to 2 comma 2 not required, up to 36 comma 36 you don't bother because they're all self, that is reflexive. Now you check from 2 to 6. Okay, so 2 to 6, then 2 to 12, 2 to 12, then 2 to 24, then 2 to 36, 2 to 36. Okay, then 3 to 6, then 3 to 12, then 3 to 24, then 3 to 36, then 6 to 12, then 6 to 24, 6 to 24 is there, then 6 to 36 is also there. Now where we don't have the continuity, one is, see here, another one is 24 to 36, there is no connectivity. So what you have to do, 2 and 3 has to be adjacent to each other. 2 and 3 should be adjacent to each other. So that is same way 24 and 36 also should be adjacent to each other. I hope you understood this. So this is 2 and this is 3. They should be adjacent. Then here 6. Then above that it is 12. Then you don't write 24 above this. 24 and 36 should be adjacent. This is 24 and this is 36. Okay, now we will start connecting them. So we have all this reflexive. So 2 to 2, then 6 to 6, okay, 3 to 3, everywhere it is there. You don't have to check directly, blindly you can do that. Okay, next what will you do? Next you see from 2 to 6. Okay, you have to see the relation and go on doing it. You don't by heart anything. See, 2 to 6 is there. Okay, then 2 to 12, 2 to 12 is there. See, 2 to 12. Then 2 to 24, 2 to 24 is there direct. Okay, then 2 to 36. 2 to 36 is also there. Okay, 2 to 36. Okay, then 3 to 6. See, 3 to 6. Then 3 to 12. 3 to 12. Then 3 to 24. 3 to 24. Then 3 to 36. 3 to 36. Okay. Then 6 to 12. See, 6 to 12 is here. This is 6 to 12. Then 6 to 24. 6 to 24. Then 6 to 36. 6 to 36 is also there. Then 12 to 24. Then 12 to 36. Okay, don't by heart. You just see the relation that you have written and accordingly connect them. Okay, so what is the next step? Next step is to remove the reflexive and transitive. So you represent it as it is. This is 2, this is 3, this is 6, this is 12, this is 36, sorry, this is 24, and this is 36. Now reflexive you remove that 2 to 2, 3 to 3, all the self it is there, no? You remove that. Now you see here there is a connection in the previous diagram I am talking about. 2 to 6 is there, 6 to 12 is there. So 2 to 12, the transitive, you don't have to do it. Okay, 2 to 6 let it be there. I will draw it with a different color. So 2 to 6 is there. Then 6 to 12 is also there. This 2 to 12 you can eliminate. Okay, in the same way here you see we have 3 to 6, then we have 6 to 12 is there, then this 3 to 12, see 3 to 6 is there, 6 to 12 there is a connection, so 3 to 12 is not required, that is transitive. So we are removing transitive now. Reflexive already we have removed. So like this you go on checking it. Then you see here we have a connection 6 to 12 and 12 to 36. So there is 6 to 36 that is to be removed. In the same way you go on reducing it. So here we have 12 to 34, 12 to 34, sorry 12 to 24 there is a connection. So 6 to 12 is there, 12 to 24 is there. So 6 to 24 if it is there, it is there. You remove it. So this much only you will get. All other things will be eliminated. Okay. Now the last step. What is the last step? Remove that circles will be replaced by dots. This you write number. So this is 3. This is 6. This is 12, and here we have 24, and here we have 36. Now just to connect them, that is solving the problem. So arrows not required here. Okay, so 2 to 6, then 3 to 6 is also there, then 6 to 12, all upwards. Okay, then this is 12 to 36, 12 to 24. Okay, so this completes the HASSE diagram. Only this much. No, you don't have to prove anything else. So through HASSE diagram only we are able to do it. Okay, now is this the just an additional information? Is this the totally ordered set? No, because there is no connection between 2 to 3. There is no connection between 24 to 36, but it is a partially ordered set. Okay, so thank you for watching this video. Two important things I have explained. Study this thoroughly.